For decades, we've been sold this one idea about security: build a bigger wall, a stronger digital fortress to keep the bad guys out. But what if I told you the biggest, most dangerous flaw in your entire security plan is the very idea of trust itself? Let's dive into why this huge shift is happening and what it really means for all of us. All right, so everything we're going to talk about today is drawn from this fantastic book, Zero Trust Security, a hands-on guide by Adam Tilmark Jacobson. It is an absolutely brilliant and practical guide that breaks down one of the most important changes in cybersecurity today. We're going to pull out some of the core ideas for you right here. Seriously, just let that question sink in for a second. It completely flips the script on how we've always thought about security. This is the one idea that forces us to basically rethink everything we thought we knew about protecting our data. So to really get why this is such a big deal, we've got to look back at the old way of doing things. The classic castle and moat model. The idea was pretty simple. You spend all your time and money building this massive wall and a super deep moat, that's your firewall, to protect all the valuable stuff inside. And here it is. This right here shows you the fatal flaw in that whole castle idea. Once an attacker gets past that one wall, and let's be honest, today they almost always find a way, they land inside what's called a flat network. I mean, look at it. It's just a big, wide open courtyard. There are no other walls inside. From that one spot, they can get to the factory, the user data, everything is exposed. And this terrifying ability for an attacker to just wander around inside your network, it's got a name: lateral movement. And this, right here, is the biggest reason the old castle and moat model fails. An attacker gets just one tiny foothold, and from there, they can just hop from system to system until they find the crown jewels. Okay, so with a flaw that big, that catastrophic, you can't just patch it. You need a whole new philosophy, one that takes on the root of the problem: our misplaced, implicit trust. And that, my friends, brings us into the world of zero trust. And John Kindervag, the guy who basically invented this whole concept, he really hit the nail on the head with this one. Zero trust isn't some product you can just buy and install. It's a complete top-to-bottom change in how you think about security. So what's the philosophy? Well, it starts with a pretty wild assumption. You have to assume you're already hacked. Assume the network is hostile territory. And if you start from there, then every single request to access anything has to be treated as suspicious. The book uses a perfect military analogy: the need-to-know principle. You only get access to the exact thing you need for your job, for that moment, and absolutely nothing else. And look, this isn't just some high-level idea. Kindervag actually laid out a super clear 5-step method to make this happen. You can see it's a very deliberate process. You figure out what's important, map out how data moves, build the new environment, write the rules, and then you watch and maintain it constantly. Now, when you put this plan into action, it's formally called a Zero Trust Architecture, or ZTA for short. And this is not some fringe concept, folks. It's become the industry standard. In fact, if you want the official playbook, it's all laid out in this really important document from the National Institute of Standards and Technology, which everyone just calls NIST SP 800-207. All right, so that's the what and the why. But how do you actually do it? How do you build this thing? Let's get into the nuts and bolts, starting at the very foundation, the network itself. So remember that lateral movement problem we talked about? Well, the first move is a direct counter to that. It's called network segmentation. Instead of one big open field, you're building a bunch of small, secure, isolated zones inside your network. That way, if an attacker gets into one zone, they're trapped. They can't move anywhere else. And there are basically two ways to slice this. You've got physical segmentation, which is exactly what it sounds like. Totally separate wires, separate switches. It's super secure, but man, is it expensive. Then there's the much more common way, logical segmentation. This uses tech like VLANs to create those same secure zones, but on the hardware you already have. But here's where it gets really cool. The ultimate goal in Zero Trust is to take this idea to the extreme, to a level called microsegmentation. Forget just building walls between departments. Imagine putting a secure little bubble around every single server, every laptop. And here's the key. By default, nothing can talk to anything else. Communication is only allowed if there's a specific security policy that says, okay, you two can talk. Okay, so we've put up all these internal digital walls. Awesome. But now we have to figure out who or what gets to go through the gates, right? This brings us to the next massive piece of the puzzle, verifying every single identity. And the whole discipline that handles this is called IAM, which stands for Identity Access Management. You can think of IAM as the ultimate bouncer in your zero trust club. Its entire job is to make dead certain that the right person is getting access to the right thing at the right time and for the right reason. Now, one of the absolute non-negotiable rules of modern IAM is MFA, or multi-factor authentication. We've all used it. The idea is so simple, but so powerful. A password by itself is just not good enough anymore. To prove you are who you claim to be, you need more than one kind of proof, like a password you know, plus a code from a phone you have. Okay, so MFA is great, but asking people for 3 forms of ID every 5 minutes would drive them crazy. That's where SSO, or single sign-on, comes in. It's a game changer. Instead of juggling 20 different weak passwords, users get one super strong MFA-protected identity to log into everything they need. It's a massive win for security and, honestly, a massive win for everyone's sanity. All right, let's recap. We've chopped up the network into tiny pieces. We are verifying every single identity trying to get in. But are we done? Nope. Because remember the core principle? Assume you're compromised. We still don't trust anyone. And that leads us to the final crucial pillar. You have to watch everything all the time. So how do you watch everything? Well, on the front lines, on every single laptop and server, you use tools called EDR. That's endpoint detection and response. Just think of it like a little security agent living on every machine, constantly watching for anything suspicious, and ready to shut it down in an instant. But having thousands of security guards that don't talk to each other isn't very helpful, right? They all need to report back to a central command center. And that's exactly what a SIEM does. Security Information and Event Management. It's the brain of the whole operation. It collects all the reports from EDR, from firewalls, from everything, and puts it all on one screen so the security team can see the big picture and connect the dots. And there you have it. That's the blueprint. Network segmentation, strong identity, and continuous monitoring. It's a complete shift away from that old hard on the outside, soft on the inside model to a system that's smarter and tougher all the way through. It's not about keeping people out anymore. It's about making sure that no one, inside or out, has more power than they absolutely need. Which, of course, leads to one final question for you. Hey, if this breakdown helped you wrap your head around this massive shift in security, it would mean a ton to us if you'd support the channel. Hitting that like button and subscribing, well, that's what lets us keep making more explainers just like this one. Thanks so much for watching.